Okay, geometric proofs. Yum. Let's, what are we going to do here? Let's prove, so what we've got here is these two angles are the same. So we know that's an isosceles triangle, and an isosceles triangle, that means those sides are the same. Let's prove it. So our task is to prove that that's the same as that. Let's see how we go. So, angle DBA, DCA, given. Angle CDA, that one, equals angle BDA, which is that one, because they are adjacent. Ran out of room. Adjacent angles add to 180. So if that one's 90, the other one's 90. And how about AD is AD common? So what we can say is triangle ABD is congruent to triangle ACD by, what's that going to be? Angle, side, angle, side. So that's angle, side. Because of congruency, we can say, therefore, AB equals AC. Right, so AB and AC are the same length, proof done. Here, we want to prove that CD and AB are parallel. We are not told they're parallel. For some strange reason, we know they're parallel, but the challenge is to prove it. I'll try not to run out of room this time. Okay. Let's go. AE equals DE. So AE and DE. We're also going to say the same for those two. CE equals BE, given. How about angle AEB equals angle CED, vertically opposite. Oh my gosh, I think I've got a side, an angle, and a side. So remember, they've got to go in that order. So side, angle, side, side, angle, side. So triangle AEB is congruent to DEC, side, angle, side. Right. That hasn't proved really anything other than because of congruency, we can say angle ECD is the same as angle EBA. Because they're congruent, those angles have to be the same, so they need to be the same. They have to be, don't they? I could say the same thing about those two angles. They are the same because they're congruent triangles, but we don't need that. Okay. I'm going to get my little red pen out because we're home and hosed. I've just extended A, B and CD, and I've drawn a transverse line. Now, if I was in class, I'd actually physically get your book and turn it round so it looks like the Z rule. But if that angle and that angle are the same, then that's the same as parallel lines and a transverse line. Wow, you can sort of see that with all that red, can't you? So we can say, therefore, AB, whoops, that's dodgy, is parallel to CD because alternate angles are equal, and proof done. In the exam, try not to put so much red ink everywhere. Okay. We have a parallelogram WXYZ. Let's prove that a diagonal cuts a parallelogram into two congruent triangles. Okay, so our eyes are very useful. Can you see that I've got parallel lines and I can say angle XWY equals angle ZYW because they are alternate. Let me rub that out. Clearly in the exam you're allowed to do that in pencil. Okay. If you turn your book around, you can see the Z there. So I can say angle ZWY is angle WYX because they are alternate. What else can we say? See that WY, it's the same as WY, it's common to both triangles. And oh my gosh, I've got, I guess I should have left that in red, angle, side, angle, ASA. So therefore, triangle WZY is congruent to triangle, you got to get this right, what did I say, WZ, so that will be YXW because of angle, side, angle. They're sort of fun, but sort of not fun. They can be tricky, so you've got to do as many as you can so you're ready for the test. Good luck, hard work.